In the problem we have here, we have a man holding a spring with an unstretched length of L and a stretched length of L prime, and it has a board attached to it of weight W. And we're given that the unstretched length is 0.25 meters, and the length of the board is 1.01 meters. The height of his hand above the ground is 1.54 meters, and the weight of the board is 92.0 newtons. Now what we want to figure out is what is the spring constant K. Now we're told that the board goes all the way down to just about touching the floor, so that's going to be where 1.54 meters is. So the very first thing we do is we want to determine what X is. We've called the positive upwards, so X is our stretch in the spring. Stretch in spring. Okay, so we can see that our stretch in the spring is going to be this distance from L to L prime. So X is going to be equal to basically L prime minus L. Okay, what is L prime? L prime is going to be, if this is L prime here, it's going to be 1.54 minus the length of that board. So we're actually not given the L prime, we have to calculate it from the total distance minus the length of the board. Our total distance is 1.54 meters. Minus the length of the board of 1.01 meters. Now subtract off L from that, which is 0.25 meters. Okay, and that'll give us X, our stretch in the spring. And if we all plug that all in our calculator, we get an X of 0.28 meters. Okay, now we just have to look at the forces in order to determine what the spring constant is. So we can say we have a force down weight here, force up, this is the spring force. We know that the spring force is equal to K times X. K being our spring constant, X being our stretch in the spring. And if we say the sum of the forces is equal to 0, so we add up all our forces, we have Fs positive minus W, the negative weight, equals 0. So we can say Fs equals W, the weight. So rewrite this over here. We have Fs is Kx equals W. Means that K equals W divided by X. Just by dividing X to the other side. Now we know W is 92 newtons. Let's plug in our numbers. 92.0 newtons divided by X of 0.28 meters gives us a number of 328.57 newtons per meter. So now what we do is we just round off. K equals 329 newtons per meter. That's our spring constant. That's our final answer.